a sequence can be any list of numbers. Usually they are related somehow or another. 3, 6, 9, 12, 15, blah, blah, blah. Any list of numbers really can be a sequence. That's a sequence, and we'll talk about several others. Just some notation, just so we're all on the same page, I think probably okay. Usually the first term, A1, second term's A2, A3, so forth. And so in this case, we could say, if I wanted to name my sequence, couldn't I say that A sub n is 3n, where n starts at 1 and then proceeds on from there? And usually that's where you start. You don't have to start at n equals 1, but wouldn't that be A sub n equals 3n? And so that would give us a nice, easy way of coming up with the terms. A sub 10 then would be 3 times 10, so that's 30. And so, yeah, getting that generating expression is usually a good thing to have. And so that's one way that you'll see it written. But they'll also use kind of a even more abbreviated version of it and have just braces to designate that that you're talking about a sequence. And so, yeah, that's just some notation. Now, as far as graph is concerned, if I were to graph this sequence, 3n, since on sequences I'm usually just talking about the positive integers, the graph is just, it's not a connected sort of thing, but it is similar to what we usually do. A sub 1 is 3. A sub 2 is A equals 2, we've got 6. 3, we've got 9, so forth and so on. So usually the graph, if you graph the sequence on your XY axes coordinate system, it's just a series of dots. So if they refer to that. Okay. All right. What about this sequence here? First 5 terms. Well, that one's just saying every n value do the reciprocal, or other ways you look at it, but you got 1 over 1, you got 1 over 2, 1 over 3. It's the fractions. First 5. Of course, 1 over 1 is 1. All right. One of the concerns we'll have with these sequences, of course, are limits. As n goes to infinity. And this is stuff we've talked about before. What about that limit? We're talking about the limit. Back to that sequence there. Is there a limit? Yeah. If n goes to infinity of the 3n sequence, n is just getting larger and larger, so 3 times n is getting larger and larger. That's infinity. Now, on the other hand, this sequence does have a limit, right? As n goes to infinity, that would go to 0. All right, and so for that reason, then, the series 3n is divergent, just as before, and the series 1 over n would be convergent, just as before. Same idea, right? Convergent if it goes to a finite number, divergent if it goes to infinity, negative infinity, something like that. So that notation, symbolic notation, is the same. All right. One other sequence that we'll encounter a lot, not just by itself, but within other sequences. A sub n is negative 1 to the n, is a special type of sequence because what happens there? Well, again, if we start with n equals 1, that sequence goes negative 1 to the 1, which is negative 1. Then I go negative 1 squared, which is positive 1. Negative 1 cubed then is negative 1. Negative 1 to the 4th is positive 1. So that's the alternating signs, and we'll utilize that quite a lot within other sequences. It gives us a way to alternate signs. For example, a sub n is negative 1 to the n times the 1 over n, which is the one we just talked about. But if we throw the negative 1 to the n onto it, what's that going to do? Well, instead of all positives, it's going to alternate, right? Because negative 1 to the 1 times 1 over 1, that gives me be negative 1. And then negative 1 squared be positive 1 times a half, so that would be positive a half. Negative 1 cubed be negative 1 times a third. Yeah, so that gives me a way to do alternating sequences where the terms alternate positive and negative. Okay? Now, one of the things they like for us to be able to do is come up with sequences on our own, or come up with the expression for sequences, the a sub n. So if I have 1/3, negative 1/4, 1/5, negative 1/6, blah, blah. What's a sub n there? Well, a couple of things to look at. Obviously, we're alternating. And so what does that mean? Well, if we're alternating, that means I'm going to have to involve this negative 1 to a power part of it. However, there's a slight problem. Why can't I just do negative 1 to the n? What would be wrong with just doing negative 1 to the n? Again, the way we'll start this is n starts at 1. So why can't this be just negative 1 to the n? Well, if I start at negative 1 to the n, won't that give me a negative first term? Because negative 1 to the 1 gives me negative 1. So that would give me a negative first term. So I can't just do n here. How can I fix it? Well, there's a couple ways. How about n plus 1? Wouldn't that fix it? Where it would be a positive first term, negative second term, because the first term would be 1 plus 1, which would be squared, so negative 1 squared. Now the other part, the fraction, well, I have a slight problem there because I'm not starting at the bottom as 1. But it is just counting up, so how we got to fix that? Start at, instead of 1 over n, start 1 over, how about n plus 2? Yeah, because everything's kind of just shifted 2 units over, right? This, instead of 1 over 1, I've got 1 over 3. Instead of 1 over 2, I've got 1 over 4. So I've just added 2 to each denominator. With me? So those are just some things you have to think about when you're coming up with your own sequence there. But yeah, if it's alternating, you always have something like that. All right. Okay, well, how about 1/4, 1/8, 1/16, 1/32? Not alternating there, but we might want to notice that, what are my denominators there? They're all even, but they're more than that because I don't have all the even numbers there. What are all these denominators? Huh? Multiples of 4? If you don't have all the multiples of 4. So that's not quite it because, yeah, that's 4 times 1, that's 4 times 2, but that's 4 times 4, that's 4 times 8. So it's not multiples of 4 that we want. Sometimes it might be if we had a fourth, an eighth, a 12th. Good try. But what are those? Aren't these powers of 2? Yeah, they're powers of 2. That's 2 squared, and they're consecutive powers of 2, right? So that's good. I want consecutive things. This is 2 squared, that's 2 cubed, that's 2 to the 4th, and that's 2 to the 5th. So we're good. So how can I get that in a series? How about 1 over 2 to a power, but it's not 2 to the nth power because 2 to the nth power would not start at 1/4, would it? 2 to the nth power would start at 1/2. So I'm leaving off 1/2. So how can I remedy this? Same way I did it down here, right? Basically. Make it 2 to the n plus 1 power. Because then the first one would be 1 plus 1, so that's 1 over 2 squared. The second one would be 1 over 2 plus 2 to the 2 plus 1, so that'd be 1 over 2 cubed. Yeah. Okay? All right. How about this one? How about negative 1, 1/4, negative 1/9, 1/16, negative 1/25, etc., etc., etc. What's my a sub n there? Well, first of all, have the alternating thing. So what does that mean? That means I need to do negative 1 to some power. Will n power get it this time? Yeah. I think the n power would be the one I'd want here because that would start me off at negative, and then the next would be positive, and the next would be negative. So instead of n plus 1, I don't want the n there. Now what about the rest? Well, again, it has to do with the denominators, doesn't it? This is times 1 to, what are the bottom things here? What are they? Squares, aren't they? Yeah, these are squares. 2 squared, 3 squared, 4 squared, 5 squared. And even this one works because the denominator here would be 1 squared, wouldn't it? So yeah, these are the squares, n squares. And we do want to start with 1 squared, bottom 2 squared. Okay? So it's just some different ways of thinking. Okay, one more. Four fifths, 9/25, 16 1/25. What's a sub n there? We don't have the alternating part. Basically what it amounts to is, for these anyway, you know, you look for powers, you look for multiples. What do you see? The tops are the squares. However, I leave off 1. I don't have 1 squared. This is 2 squared. That's 3 squared, 4 squared. So yeah, I'm going to have to do the shifting over thing. I don't have 1 squared, so I need n plus 1 squared. Yeah. With me there? N plus 1 squared would give me that. Then the next one would give me 3 squared. And then the next would be... Is that okay? What about the bottom? Powers of 5, yeah. That's 5 to the first, 5 to the second, 5 to the third. Yeah, powers of 5. So we'll go here. 5 to the nth power. Do I need to plus 1 or anything? No. 5 to the 1 is the first, 5 to the second. So again, we always start at n equals 1. So n plus 1 squared over 5 to the n. Sound okay? All right. Now, Another question then we shall ask is, I think I'll go to this one, then I'll come back to that one, if I can remember to do that. Okay. Determine if a sub n equal 7n squared over n plus 6n squared converges. Okay, well, we said that just as before, how does something converge? Well, if its limit a sub n converges, that sequence, if what? The limit as n goes to infinity of a sub n goes to a finite number? Yeah. So the question, does this converge? I'm going to look at the limit of that sequence. As n goes to infinity. And see if that goes to a finite number. Okay? Now, we know a few things about doing these limits. So we recall back, we've got L'Hopital, we've got other. What do you want to use there? We could use L'Hopital, couldn't we? L'Hopital would work there, wouldn't it? Because you got infinity over infinity. Or 0 over 0, yeah. Infinity over infinity, so you could use L'Hopital. Way back, I think in Calc 1, we did this one a different way. We divided by n squared, top and bottom. You could do it that way too. Either way, I think it'll work out. Probably direct answer wise, we get quicker doing that way. That's whatever you want to do. If I divide both sides by n squared, or top and bottom by n squared, we'll have 7 over, what would be 1 over n plus 6. Yeah, so that's 7 over 0 plus 6, because that goes to 0. 7/6. It converges. Okay? What about this one? A sub n negative 8n cubed over 9 minus n. Convergent? Same thing, isn't it? Limit as n goes to infinity, what happens? Negative 8n cubed 9 minus n. Well, if I divide by n cubed, that way, going about this, there we'd have, what, negative 8 over 9 over n cubed minus 1 over n squared. So divide that by n cubed, you get 1 over n squared. It's the limit as n goes to infinity. What happens there? Oh, I did that wrong, didn't I? Wrong. We don't want to divide by n cubed. What do we want to divide by? Remember, we divide by the largest power in the denominator. So let's divide by n. Just divide by n. So that's the limit as n goes to infinity. Negative 8n squared over 9 over n minus 1. Well, that goes to 0 as n goes to infinity. What happens here? N goes to infinity. That goes to n squared goes to infinity. So negative 8 times that would go to negative infinity over 1, negative 1, but that's still going to be infinity, positive infinity. So that one's no, not convergence, divergent. All right, one more. A sub n is Ln of n over n. Is that one convergent? Well, what's the limit as n goes to infinity of that? Well, that one is one where we'd use what? That would be L'Hopital, isn't it? Because that we don't have our little trick, divide by the power there. Because we've got Ln of n. But as n goes to infinity, that goes to infinity. As n goes to infinity, that goes to infinity. So yeah, if we L'Hopital this, what's L'Hopital? Better do this. L'Hopital says, if you got infinity over infinity, then do the limit of what? Derivative of that over derivative of that. Derivative of Ln of n. What's the derivative of Ln? 1 over n. It's the derivative of n. 1. So what have I got? The top goes to 0 over 1. 0. Convergent. Converges to 0. With me? Okay. All right, so yeah, let me go back to this one. A sub n equals negative 1 to the nth times 1 over n. Let's talk about whether or not that one is convergent. Because we have, remember this one was 1, 1/2, 1/3, but they're alternating. Starts off with negative 1, then it's positive 1/2, then negative 1/3, 1/4. So we haven't yet talked about one such as that. Well, here's the thing. There's a theorem in this section that states this. If the limit as n goes to infinity of the absolute value of your sequence, if that equals 0, then the limit as n goes to infinity of a sub n equals 0. That theorem comes into play here. Because what does that do? What does this do to our sequence here? Well, the absolute value of my a sub n would be the absolute value of negative 1 to the n times 1 over n. What does that do? Well, since I'm doing the absolute value, everything, so I'm not talking about anything being 0, that makes everything be positive, doesn't it? Basically, it takes out the negative signs. Because if I'm doing the absolute value of 1 over n, wouldn't that just be 1 over n? You see what I'm saying? If I do the absolute value of this sequence, that takes out this part, right? It takes out the negative, alternating negative signs. So it just turns into 1 over n. So what is the limit as n goes to infinity of the absolute value of a sub n? Well, like we just said, that's going to be the limit of n goes to infinity of 1 over n. 1 over n, that does go to 0, doesn't it? So this theorem says then, if that goes to 0, then your a sub n goes to 0. Limit. So that limit is 0. So it's convergent to 0. Okay? But the absolute value does have to equal 0. It can't equal any other number for that to work. So that one is convergent, even though it bounces between, and you can kind of see it if you graph it out. At 1, you're at -1. At 2, I'm at positive a half. At 3, I'm at -1/3. At 4, I'm at positive 4. So, I mean, it does seem like these are coming up to 0. These are coming down to 0. So, anyway. But that theorem allows us to do that. Okay. A couple other things. Another sequence that they introduce here is the geometric sequence. So let's talk about it. And as you are probably already familiar with, a geometric sequence is a sequence that has a common ratio. Between terms. A good example is the powers of 2. 2, 4, 8, 16, 32. That's a geometric sequence because there's a common ratio. If you take 4 divided by 2, you got 2. If you take 8 divided by 4, you got 2. 16 divided by 8, you got 2. Or another way you can look at it is each term, you get the next term by multiplying it by the same number, right? Here you multiply by 2 to get 4. Here you multiply by 2 to get 8. So yeah, it's another way of looking at it. But the ratio is important because, well, there's a lot hinging upon the ratio. And here the ratio is 2. The common ratio is 2. Okay? Now, one thing we also should note there, if I wanted to write that in a sub n format, it'd be 2 to the n. If I have a sub n equals 2/3 to the n, well, that's 2/3 to the 1, so that's 2/3. 2/3 squared would be 4/9. 2/3 cubed would be 8/27. Yeah, again, I get a geometric sequence. A sub n equals -4 parentheses to the n. That'll give me -4, positive 16, negative 64, positive 256. Isn't that geometric also because I'm multiplying each time by -4? R equals -4 here, R equals 2/3 here. It's also geometric. A sub n equals 5 times -1/2 to the n plus 1. Is that one geometric? Well, let's see. First term would be 5 times -1/2 squared. What did I say? 5 times -1/2 squared, which is 5 times 1/4. It's 5/4. A2 would be 5 times -1/2 to the 3rd. So that'd be 5 times -1/8. That's -5/8. A sub 3 would be 5 times -1/2 to the 4th, which would be 5 times 1/16 positive, which is 5/16. Is it looking geometric? I believe so, because what am I multiplying each time by? Multiplying by -1/2. Right? Multiply that by -1/2, you get -5/8. Multiply that by -1/2, you get positive 5/16. Yeah, this is geometric too. So all 4 of these are geometric. My point of this being is the distinguishing characteristic of a geometric sequence, we've got n to a power in exponential. This one's n plus 1, but it is exponential. Okay? Geometric sequences, yeah, they're exponential expressions. meaning the n is in the exponent. So yeah, if you're looking at a sub n and it's got the n in the exponent, might want to check that for being an exponential. Then the other thing is on the convergence, geometric sequences, I'll just make a note here, converge if, well, it turns out if r is in between -1 and +1. And it could be equal to 1. So if the r is between, and so, yeah, if I come across a geometric sequence, if my r is between -1 and +1, it's convergent. If it's not between -1 and +1, it's divergent. So back to these, and they probably go through it a little more in the book there, but out of these four, what do you got? Which ones are convergent? Which ones are divergent? It's obvious on this one it's divergent, but the r is 2. That one's divergent. This one, the r is 2/3, right? So that one's convergent. Here, you're alternating, but it's r is -4, so that one's divergent. And this one, we got r is -1/2, so it's also convergent. So it's real quick, easy. On geometric sequences, if r is between -1 and +1, they're convergent. Okay, got one more deal for you. And that is, they talk about increasing and decreasing sequences. And it's just like you would hope. Okay, a sub n equals 2 to the n. That's an increasing sequence. Why? Because the terms get bigger and bigger. Okay. The way they usually write it is the a sub n plus 1 term is greater than the a sub n term. So you take a term and then the term, this would be the term after it. So if the term after it's greater, it's an increasing sequence. Fairly obvious. Okay, yeah, this one, you got 2, you got 4, and then 8. Yeah, that one's definitely almost obviously it's increasing. Decreasing, well, it goes the other way. A sub n plus 1 is less than. So the term following your a sub n term, if it's less, then you got yourself decreasing. A good example of that is a sub n equals 1 to the n. Decreasing. 1, 1/2, 1/4, 1/5. What happened to my third? 1/3, 1/4. Yeah. Each term is smaller than the previous term. It's decreasing. Okay. Monotonic, that's a different term. What monotonic means, a sequence is monotonic if it's either decreasing or it's increasing. In other words, it's doing one thing or the other. So, both of the previous sequences I've got right there are monotonic. A sub n equals 2 to the n, that's also called monotonic. A sub n equals 1 over n, that's monotonic because 2 to the n is increasing, 1 over n is decreasing. So if it's one or the other of those, It's also referred to as a monotonic sequence. Okay? All right. Now, what about this one? Is a sub n equal negative 1 to the n times 1 over n? Previous sequence we've looked at. Is that one monotonic? Well, let's look at the terms. What are the terms of this? It starts at negative 1, then it goes positive a half, then negative a third, positive a fourth. What you got there? Is that one increasing? Well, it increases there. But what about there? 1/2 to negative 1/3. That decreases. That one increases again. So no, it's not increasing, because to be increasing, all the terms have to be increasing from one to the next. Is it decreasing? Same deal. Obviously not. So is it monotonic? No. Okay. So yeah, the alternating ones are not going to be increasing, decreasing scenario.